Good afternoon, ladies and gentlemen. My name is Lotta Sartz, and I will be your host during this afternoon. I'm sitting in a studio at Örebro University, together with some of the panelists for today. And we would like to start with a big welcome. And with me on link is Jenny Greberg, Program Director for Swedish Mining Innovation. Jenny, could you say a couple of words why we are here today?
Thank you, Lotta, and hello everyone. So welcome again. As Lotta said, my name is Jenny Greberg and I am Program Director for one of the 17 national strategic innovation programs that we have in Sweden. And this is the one that deals with mining. So it's called Swedish Mining Innovation. Our program is an industry program with funding from industry partners, but also from Vinnova, Formas and Energimyndigheten. And we are working to increase the competitiveness of the industry, but also to secure a sustainable supply of raw materials, meeting society's needs. And we are doing many things in the program. We are funding innovation projects, pilot projects, feasibility studies, and we're also organizing workshops and other types of events. We also have competitions for SMEs and we have an innovation award. We also have a PhD network where all PhD students working in related areas to mining are welcome to join. Last year, we got extra funding from Vinnova to try to investigate what AI can do for the mining industry. And as a result of that, we had a workshop about a year ago with attendance from both industry and academia and other research providers. This workshop was very appreciated, and one of the outcomes was that we are lacking a forum where we can discuss how mining and AI can work together and what's AI solutions that can actually help the mining industry forward to meet the ambitious goals regarding sustainability and so on. Most of us in the Swedish Mining Innovation Program are located and based in Luleå, but I'm very happy that since November 2020, we have launched an extra focus on Bergslagen and the Bergslagen area. And our colleague Lotta Sartz is the person we have appointed to that task. And we're doing this together with Örebro University and Region Örebro, and also some of the industry partners in the Örebro region. And this is, of course, one of the reasons that we're having this workshop broadcasted from Örebro today. Another reason is that we know that in the Bergslagen area and in the Örebro region, we have many actors that are specialized in AI. Of course, Örebro University, but also Epiroc working with equipment, and also some SMEs that are very highly competent within this area. So I'm very happy to welcome you again today, and I'm now going to leave the word to Lotta again. Thank you.
Thank you, Jenny. Before we kick off with the presentations, we also invite Irén Lejegren, Regional Council of Örebro, to say a few words.
Thank you and good afternoon, and thank you for the invitation to give a short opening remark of this conference. My name is Irén Lejegren and I represent Region Örebro County. The theme for today is autonomous systems and artificial intelligence, both emerging as the key technologies of innovation, sustainable industrial development, growth of new jobs, and societal development. For us as a region, the theme is very important and exciting also, given our strong academic position through Örebro University and the opportunities that the application of knowledge and research can bring to our industry. We have several innovative companies in this sector around us, many of them represented in the initiative we are focusing on today's event. It is also very encouraging to see the collaboration with the National Strategic Innovation Program, Swedish Mining Innovation. New technologies move fast. This is true, not least in the field of AI. Countries and regions are currently investing large sums in infrastructure, research, education, and innovation in AI. Investments are also being made to support industry competitiveness and to solve societal challenges. Expectations are very high. According to a report made in 2020, the economic value of implementation of currently available AI technologies only in Swedish public sector is really significant. Örebro University is moving very fast in this field with very impressive results. The research environment at Örebro in AI and autonomous systems has more than 60 researchers. They work on basic research, applied research, and also providing lifelong learning in AI. Since 2017, the region has supported this domain through our innovation strategy, where we have stated high ambitions for our collaboration, and we are seeing very exciting results. Together, we as a region and Örebro University are making efforts towards knowledge transfer and collaboration, and we position ourselves as a key player in the national AI context. Our commonly funded AI Impact Lab is now in many ways a role model for collaboration. A regional project is also set up to deliver different pilots on AI. Region Örebro County carries the political responsibility in coordinating and accelerating regional development. And from that perspective, we are looking ahead with great confidence that what the future of this field will bring to our region. It will benefit the citizens of Örebro region, our future sustainable industry, and the public sector. Thank you and have a good conference.
Thank you so much, Irén. And a final welcome from Johan Schnürer, Vice Chancellor, Örebro University.
Dear webinar participants, my name is Johan Schnürer. I am the proud Vice Chancellor, Rector of Örebro University. I'm pleased to welcome you to this seminar on AI and the mining industry. It is organized together with the university and the Swedish Mining Innovation Initiative. Speaking of innovation, I'm very happy that we are broadcasting this webinar from our new innovation arena, an arena meant to gather and collect thoughts and ideas from students, researchers, industry, and the public sector. Some of the challenges that this innovation arena hopes to address are those we share together with the mining industry and the metal processing industry, namely to find solutions for clean and renewable energy. United actions will increase our knowledge on how to mine and extract minerals in a safe and efficient and sustainable way. I'm very pleased that we cooperate together with Zinkgruvan, Boliden, Epiroc, County Region Örebro, together in the Swedish Mining Innovation Initiative to find solutions to some of the pressing problems of our time. During this webinar, you will have the pleasure of listening to speakers from a number of sectors, providing thoughts and insights in how AI and digitalization can provide an efficient mining industry and an efficient extraction of minerals. I wish you the very best with the webinar and look forward to welcome you back to Örebro University and the Innovation Arena in safer times.
I hope you feel really, really welcomed. Some administrative information. There is a chat function that you can use for technical issues, and then you send a private message to Elin Sandberg. And there is also a possibility to ask questions in the Q&A function. So it's time to introduce our first speaker. It's Daniel Gillblad, co-director Scientific Visions at AI Sweden. Daniel is an experienced and an analytics expert, researcher, and manager with a history of working with both academia and industry. And Daniel, welcome. You will talk about AI, what it means, and how we accelerate the use in Sweden.
Absolutely, thank you so much. Nice to be here. I'm going to speak a little bit about AI, how we accelerate the use in Sweden from an AI Sweden perspective. So let me see if I can share my screen with you. And I hope we're on the right slide. So AI Sweden is the National Center for Applied AI. We try to help public sector, government agencies, companies, and so on to accelerate the use of AI across society. So let's talk a little bit about how we do that, but start with what is the perspective of AI that we have to look at today, and where and how can it be used, and what are the challenges involved? So, of course, you know AI as a set of technologies that can provide real value in lots and lots of different types of systems. In a sense, AI is typically computer programs that can do things that previously perhaps just humans could do with some kind of precision, like looking at images and interpret them, understand natural language, learn from experience and things like that. But the perspective of AI as a general technology that can be applied more or less everywhere to make companies and products smarter is perhaps an even more important one. We can already see it today in lots of, for example, services, smart services to us as consumers and so on, in development of new drugs, in soon we'll see it in our stores and so on with automatic checkout and things like that. But perhaps more important for the mining industry is the perspective of AI that is perhaps not always visible to us as end consumers and so on. The efficiency part, the part where AI makes things smarter, more efficient, resource effective, and so on through prediction, planning, looking at how we maintain our equipment, how we optimize our supply chains, and so on and so on. And here, of course, the mining industry shares a lot of challenges together with a lot of different other kinds of industries, sometimes surprisingly so. I would say that the mining industry probably share some problems with Swedish healthcare and actually perhaps even media production companies and so on. But there are lots of commonalities within AI today. And something that we usually talk about, and this is a bit of a personal perspective, of course, but we've been talking a lot of time about machine learning, which is a core technology of the AI revolution today, letting machines look at data, learn from data to perform some kind of task instead of telling computers exact instructions on how to do these things. This is proven to be extremely efficient. And we've been talking about these things for a very long time. We've been talking about them being mature enough, deployable in real systems, and they are used all over. But there are some real practical limits to its applications, and there will be a lot of new challenging applications that will actually help us guide the development of these models and machines further. Because the current AI revolution is a lot based on machine learning and learning at scale from lots of data with lots of compute power into very, very big models. And of course, you know that today we can do a lot on the, for example, computer vision side with a set of models that are really super accurate in some cases about identifying objects and classifying content in pictures and stuff like that. But what we're also seeing is that in the last couple of years, we've been really, really good at developing models to, at least in a sense, understand and being able to interpret parts of natural language. And we see really, really nice applications coming out of this, basically. But together with this, of course, we've said that, yeah, machine learning and AI, it's mature, it can be used, you should deploy it. But now, when we're talking to companies, to organizations and so on, we actually see a slight shift in perspectives and so on. We do see a shift already in some companies from, let's say, machine learning to machine reasoning. And I'm not saying that we build intelligent machines that can reason about things, but more about complete systems that can actually use these learning systems, predictive systems and things like that, and putting them into context and actually automate decisions and things like that. We talk a lot more about not necessarily developing new applications from scratch all the time, but actually build on others' results, both in terms of methods, but also in terms of already available models for languages, images, and all that kind of stuff. And all of this means that a lot of more material and experience can be shared in an efficient way. Something that's also sort of changing in a lot of companies, and it's a very, very good development. And this is a bit vague perhaps, but we talk a lot more today about AI than necessarily just data science. And I think this is a relatively good perspective to have, because quite often data science became something that we should take a data set, develop some kind of model on top of it, and let's see what we can use it for. Today, more and more organizations are talking about AI as a complete transformative technology. So how do we really rethink what we do? Where can these processes be applied? What can we learn? What can we automate? What can we optimize? So we're moving more towards a focus on application, more towards a focus on organization and these kind of things. So since these perspectives are changing and so on, so where do we go now? Of course, there's a lot of work on real world deployment, getting this stuff out in real running systems. But sometimes to do that, we also need to focus on a little bit on expanding the scope of AI, the applicability of AI. Where can AI sort of live, work, and in what environments is it actually useful? So these two are very much in focus for AI Sweden, because these contain a lot of the things that make it difficult for organizations to develop and apply AI today. Of course, we also see a push towards bigger learning systems, wider learning systems that can do more things and can work towards more cognitive, real, let's say, intelligent systems. But we focus more on developing the technology that we know have huge value today to real applications. And it can be sort of daunting looking at how to really apply these things in real life, because all of a sudden the systems can become a little bit complicated. It's not just software anymore, it's data, it's models, and you have dependencies on all kinds of services and already built systems and so on that are even more complicated than many of the software systems that we live with today. So that's a little bit of a challenge, but also is a challenge when you move from lab to real world applications, other things become important. You need to evaluate these models and methods in a different way. It's not just one specific parameter that sometimes when we write research reports that we focus on, all of a sudden it's different things that really matter. And just a fun example is this image down below here, which was spread out on social media a few weeks ago. It's a small part, but it sort of points to the fact that when you deploy these things in real life, looking at, for example, doing automated texting of speech, these models need to be continuously updated. Otherwise, well, if you speak Swedish, you end up with these things like smittspridning av covid-19, which should, of course, be something quite different. So how do we expand the scope of AI? Well, we need to look more and more to where does AI live? Perhaps it doesn't just live in a data center. It needs to live on the edge, in our devices, in cars, in radio base stations, and so on and so on. So what does that mean for our systems, our models, and so on? We talk a lot about data access and sharing and so on, but data is quite often stuck. So how do we move around that? How do we interact with these kinds of systems, and what does it mean for the precision that they need to provide? What kind of explainability do they need to provide, and so on? And all of a sudden in the real world, you have robustness constraints, you have safety constraints and things like that. And all of these things need to be explored and made better, basically. And all of these should rest on real efficient systems and platforms for AI. So if you look at from a company or organizational perspective, a lot of things become important if you really want to apply AI in a really, really thorough manner. Of course, you need strategy, but if we talk to companies that say, should I develop an AI strategy? We typically say, no, you should have a real business strategy which incorporates AI. And that's a slightly different perspective. And to do that, you might need to work with people. You need to build an ecosystem that you might not have everything in-house. You need to change the mindset of people who work within the organization. Perhaps you need to reorganize, change the processes, structure, how you approach projects and so on, because this is a very explorative way of building systems and services, basically. Yes, you need technology. Yes, you need data. But as you see, these things are just part of what we believe is totally necessary to really drive AI transformation. And we want companies to move from a foundational understanding to experimenting with these things to actually putting it in operational scenarios, and even move further than that to integrate it in the business and really become not necessarily an AI first company, but all companies will become, let's say, producers of intelligent systems and services. And how do we use these in the best way as possible? So one perspective that we work from AI Sweden, and there are lots of them. We work with education, we work with this kind of transformation of organizations and things like that. But another tool that we try to use now is to collect common interests in Sweden. How can we solve key issues for accelerating AI in Sweden? How can we provide platforms where we can actually get together from academia, public sector, and industry to collaborate about solving these problems together, developing methods together, developing best practices together, developing models together, and so on. And if this can somehow contribute to the Swedish competitiveness and our ability to make AI available, all the better, basically. So some of the things that we are looking at right now are, let's take two of these things in a little bit of a deeper context, basically. First of all, something that emerged during the last couple of years is that a lot of companies need to build systems and models that work in Swedish and utilize the Swedish language. Here we need to take our own responsibility, not necessarily Google and other companies will do that in the same way. So we need to come together to build these kinds of systems, model and experiences and share these so that we don't have to rebuild them again and again for each authority, for each company and so on. We also build now a very large program within decentralized or distributed AI. So how do we move these things out to the edge? How do we do collaborative learning when data cannot move, when car companies cannot move data from China to Europe to the United States, but need to gather insights from different domains, when hospitals cannot share data across regions and so on? How do we exchange insights and build larger models and systems, basically? And here we have now a strategic program which lots of companies are working with, and we have already launched the Edge Lab in Gothenburg with state-of-the-art equipment to explore these kinds of technologies. So when we do this, what kind of systems and results can we sort of expect? Well, we hope we get new data sets definitely new models that we can share, and also benchmarks. How do we actually evaluate these models? For example, vision or language models in Swedish and so on. A lot of experience in terms of best practices and so on. We expect new systems, prototype development, some shared platforms for experimentation and realization that, for example, companies or government agencies can build their specific applications on, but also create some kind of knowledge strategy, leadership for Sweden, so that we can come together and really make a mark in the world. And with that very, very brief introduction, I will thank you all for the attention. And now or later, depending on the program, I will be very happy to take some questions.
I think we go on with the program, but if you could stay in the meeting, then it's and it might come up a question and some time for a question.
Mm-hmm.
Thank you, Ludwig. Now we need to go to our next speaker, but you will be here during the panel discussion as well. Yeah. Our next speaker is George Nikolakopoulos from Luleå University of Technology. And Professor George Nikolakopoulos is the chair of Robotics and Artificial Intelligence at Luleå University of Technology, leading a team of 22 people, all focusing in autonomous robots. His team participates in the DARPA Sub-T Challenge with the GLP NASA team co-star, and in 2020 they have won the second stage of this worldwide prestigious competition. And the title of George's talk is Field AI Enhancing Mining Operations. So welcome, George.
Thank you. Can you hear me? Can you see me? Can you see my presentation?
Yeah.
Yes. Okay. So I am Robot George to couple my presentation to the previous one. Thank you for the introduction. So I will jump immediately to the subject. Just say again that we are a bunch of people. I think we became 23, all working in the area of field robotics, as we say. So what we are trying to do here is to take the robots from the lab and place them in real operating conditions, for example, in a mine, a construction site, in space. So we are focusing in almost all the aspects of robots that have to do with the infrastructure, with human activities, with classical examples to be the air robotics, autonomous cars, soft robotics, space robotics, underwater robotics, just to name a few. And because we are operating in high TRL levels, because as I said, we want to place our robots outside the laboratory in the real field, we have been listed 3 times in a row from EVA, based on our autonomy technology for the drones, as in a list of most influencing technologies, I think, in the national level in Sweden. So except from that, now I will start talking about AI, field AI, as I usually say, in mining operations. And I will present in short some of our activities I will be doing the last decade almost. Okay, I started working with the field of drones maybe 15 years ago. Now it is a very common subject, but yes. So I think many of you have seen videos from me or from other scientists or engineers. Many mining companies are also hiring services like the one that you see. So here I'm showing a fully autonomous drone operating in mine exploration or a tunnel exploration mission, where you see that the robot decides itself where to plant, how to avoid the walls, how to create the 3D reconstruction of the environment. So this thing is where the AI is hidden. The thing that is an aerial vehicle doesn't matter in this case. So the AI that I'm talking is platform agnostic. So in that case, is applied in the case of an aerial vehicle. because it's more difficult to control a vehicle like that than having a mining machine, for example. The size might sometimes confuse us. We think that because it's larger, it is more difficult to control, but fortunately, it's not like this. So the drones, we are doing a lot of stuff with drones just to, let's say, demonstrate how capable are our technologies, and everything that's working on an aerial platform that is inherently unstable. It means that if something goes wrong, it will fall down. It will work for the ground vehicles as well. So this is an example of embedding AI in the device. You don't see the AI there. You see only the outcome of this, but all the perception of the environment, the reasoning, the learning are mathematics embedded on the machine. So this is a scenario that the drone or a vehicle or whatever is fully autonomously navigating through a bunch of obstacles and goes through them to continue the mission. So this is something that we call, for example, reactive navigation. It means that we embed in the machines the proper AI in order to understand the environment and take decisions or cases that have not been programmed before. So if you have a fully autonomous, let's say, carrying line with some wheel loaders, for example, then if something goes there, the robots needs to have the proper AI in order to do the proper reconfiguration. So this is the classical, let's say, focus in robotics that will happen in the last years. Now I will start showing you what is the future, what is the robotic community is working with. So as it has been mentioned in my introduction, we are participating in the DARPA Subterranean Challenge that we won last year. We won the second phase. The last phase is coming in September, so let's see what will happen. And this challenge is the challenge that is changing the way that the robots are penetrating in our human society every 10 years. So the last DARPA challenge was about autonomous cars. It was at the beginning of 2000. So maybe you have seen cars with some autonomy packages going around the desert, trying to go from one point to the other fully autonomously and going through very large distances. So these technologies at that time influenced dramatically the way that the autonomy in the cars have been evolved. And nowadays, to see or to consider buying a fully autonomous car is something that is not science fiction. The same approach, now DARPA is focusing on subterranean environments. So since we're talking about mining, this is a typical case where we have a tunneling infrastructure, an urban, other subterranean infrastructure, and of course, a cave infrastructure. So the difference between the tunnel and the cave is that the cave is fully unstructured environment. And the purpose is to deploy robots here in a way to perform specific missions. And the missions can be exploration, can be search and rescue, can be pick up and return things, and things like that. Okay, why they're doing that? Because they want to push the technology in autonomy and AI beyond the current capability, okay, in levels that maybe look science fiction nowadays, but in 10 years from now, all the concepts that I'm showing you now will be realized around us. So the team here is JPL, California Institute of Technology, MIT, KAIST, and LTU. And yes, you can read more about that. What we're developing here is the Nebula, which is the Nebula autonomy. So we pass from classical development of algorithms, for example, for navigation, in a more integrated approach. Like, for example, for this scenario, we are focusing not on the autonomy of each robot, but we are building multiple components to orchestrate the operation of multiple robots. And in this case, for example, I'm showing you some concepts that we have recently published in the Journal of Robotics. So you see a mining environment and the tunnels and the robots at the same time thrown inside to perform the exploration task and being controlled. When I say controlled, I mean high level, just give a mission, and then the robots are reconfiguring their scenario and their mission and their response. So what we are developing now, and again, I'm borrowing architecture that we're using in the NASA team, is that instead of focusing only in one block, for example, local motion planning or perception or planning for one module, we build an AI software architecture that has extreme capabilities to push the vehicles, any kind of vehicle, if it is ground, aerial, it doesn't matter, in levels of autonomy, perception, and decision that have never been reached before. So that is just a picture to show the complexity of all these components that needs to work together. And imagine that we are doing that not for one agent, but we do it for multiple agents. Right? So, for example, here you see an example of a reactive navigation, as I was saying before. The classical approach is that if somebody is throwing the ball based on, for example, artificial potential fields, a method to detect obstacles, the robot is not capable to predict where the ball will go and if the ball will hit it. But if we add components of AI on top of that, then what will happen is this: the robot will have the capacity to start predicting, I'll go here, where the ball is going and take immediate actions before the ball hits it. Okay, so this is all about reactive navigation. The robot takes decisions before the event happens and things like that. And so what we are doing is that, and what we will see in the next years, is the results of the Subterranean challenge from multiple robots. As you see here, I'm showing you in our team, we have 2 spots from Boston Dynamics, one Husky and one Rollercopter, operating in environments that look like mining tunnels. And this is equivalent to the case that we have multiple mining machines that are many actions now are focusing on automating the mining machine in the small area of operating in similar mining environments. I'm borrowing the 2 images here from a report from Boliden. So this is the future in the mining thing. And I want to give you an example, and I will finish my presentation, just 1-2 minutes more, that this is an example of, again, from the competition, that we have multiple robots doing, for example, a drifting or a 3D detailed scanning of the environment. And then we use some mathematics, AI, it's called nowadays, this buzzword, to do this stitching of the infrastructure all together. So it's an amazing result that gives other dimensions in autonomy in the mining. And actually, you should always remember this setup here, okay, that this is the next step. And all this technology can lead in applying robots in situations that we don't need any more communication infrastructure as we're doing now. We don't need any localization infrastructure as we're doing now. Okay, the robots can operate in unstructured, unknown environments. We have the tools to minimize the operating downtimes, increase productivity. We can reduce the costs, and we're talking about full safe operations with robustness and the configuration in unexpected, unknown situations. Okay. And that is the last slide. That's about creating a virtual mine and not graphics, not AR or VR, but a mining environment that can be a full test bed for deploying these robots and doing very realistic scenarios. Okay, that's I'm over time, so I will finish here. I think my slides will be also shared with you. So sorry about that. Yes. Yes.
But you will also be with us at the panel discussion at the end. Yeah, great.
Yes.
So our next speaker is here in the studio. It's Amy Ludwig from Örebro University. She's a professor in information technology and pro-vice chancellor responsible for AI at Örebro University. Previously, she was head of the Center of Applied Autonomous Sensor Systems, AASS, and she actively involved in driving the university strategy to work closely in mining regarding AI and robotics, together with the many researchers at AASS who also run concrete research projects in the area, and that's also the title of your talk.
Yes. Yeah, thank you very much for the introduction. So what I'd like to do is describe a bit about how we work particularly with industry and collaboration. Being an academic institution, I also want to just highlight a few of the different research projects, and it's very much the credit of the researchers. We are a center of about, now we're almost nearing 70 researchers working on the area of AI and robotics. And really something that characterizes a lot of the research that we do is we're developing these autonomous systems that also work with and for humans. And it's a very international group. But as a university, of course, we work on education, research, and collaboration. And mining is one of the fields, but I just want to also lift up that we look at a lot of different application areas. And in fact, if I would somehow characterize our collaboration, it's that we've had several years of experience moving between what we call basic research to the application and then really testing it. So we really like collaborating with different actors, both in our region, in our nation, but also very much around the world. And again, I want to lift how we work, because there is, for those of you who maybe feel a bit unsure about what's happening AI-wise in Sweden, there is in fact an ecosystem in Sweden regarding AI. We have VASP, which is the Wallenberg initiative that is focusing a lot on basic research. We heard from Daniel earlier today about implementation and how you can actually apply AI. We also have a lot of initiatives around education, like AI competence, that's looking at lifelong learning. And we try and mirror that ecosystem. So if you're interested in working on AI projects, just contact the university and we can also link you to what's happening nationwide. So let's go to some concrete projects. This is one particular project that actually is not so unsimilar from something that George had mentioned earlier, that has been being driven by two of our researchers, Dr. Pecora and his postdoc, who are looking at, again, not only the individual autonomous system or the individual robot, but actually how a fleet of autonomous robots can coordinate their actions. And what's very interesting is that, you can look again at this video that's basically showing you a simulation of coordinating actions between 20 different robots. But, these kinds of algorithms are taken forth very much in collaboration with our industrial partners, Epiroc. And in fact, when I came here, Ulla said, hey, that's my video. And, and that's really good, because that's what we want to do. And I think even, this particular collaboration led to more opportunities for Epiroc. Yeah. And there is a company here called Newcrest Mining Limited, which is an Australian company that was very much attracted to Sweden because of the work done by the researchers. Moving on, so we talked a lot about robots, but we also look at cases where we don't have robots. This is a project that's looking at predictive maintenance and monitoring a lot of data. And we have a lot of tools to visualize data, but Frederick talked about natural language. And one of the things we looked at was whether we can get an AI to explain very complicated trends in a simple natural language by looking at these monitoring tools that are provided by Epiroc and revealing the patterns that might not be seen by the naked human eye. And this is also very good for their customers like Zinkgruvan Mining, who may look at this and then realize how they need to improve the usage of the actual machines. We also have more planning and coordination for robotics. This is a video that is showing actually what's happening.
Vi har ju ett långsiktigt mål att få bort folk ifrån gruvan.
Switch off the sound here. You can read hopefully the subtitles. What I want to lift here is that, this is a particular case where one had the idea of coordinating again different robot arms. So here you have different robot arms that should coordinate their actions between them. But again, what I want to lift is that we have these labs and demonstrator environments at the university where we test our solutions together with the companies and with the researchers. So we want to move away slowly from these kind of lab environments to the real environment, but these kind of environments are very important for taking those steps. And again, this is a research project also led by Dr. Pecora. Then we have a very interesting area dealing more on the side of perception. So how do we measure information inside a mining environment? And one specialty that we have in our research center is perception, in particular perception when you have very sort of low visibility environments. We also have researchers who are looking at perception of different types of entities, so not just visual entities, but gas, for example. And there's been a number of projects that have been examining how you can increase the perceptual abilities of these autonomous systems. And here we've had one researcher who's worked together with several others, Martin Magnussen, who's looked at examples of how you can create sort of a good representation of the environment, even though you have low visibility. And this last one, and again, I just want to reiterate, it's just to sort of tease your appetite somewhat. This particular project that is being led by Dr. Stoyanov at the university looks at how, again, you can use sensors to track the pose of these articulated links that you have, for example, on these larger machines, and then give information to the operator or plan certain tasks so that you keep the operator as safe as possible. So as I said before, you know, developing AI and robotics that work with and for humans is something that we really want to push. And we want to do this very much in collaboration with as many people as possible. So, you know, my last sort of message is that if you're curious about what AI can do, you're curious about what autonomous systems can do in the mining field, then you're just welcome to reach out to us. We have many ways into the university, and Lotta, you're one of them.
Yep.
Yeah, we're really happy to be part of the Swedish Mining Innovation and have a look about how we can transfer the knowledge that's being produced here. Thank you.
Great, thank you. So what we say, a well-deserved coffee break. Yes.
Yeah, why not?
And we continue at 2:40 with some examples and technology visions from the mining industry. Welcome back. ger du tecken. Welcome back. Hope you had some nice coffee. I would like to introduce our next speaker, Nikolakopoulos from LKAB. Nikos has a PhD in mining engineering with specialization in experimental blasting, including method and instrumentation development. Currently, he's working as senior research engineer at LKAB and as senior lecturer at Swedish Blasting Research Center at LTU. He's currently working on testing cutting-edge technologies for automated inspection of production areas in mines. Welcome, Nikos.
Thank you very much. Welcome to the presentation. Today I will talk about technological advancements that LKAB has achieved so far, as well as the potential future technologies that LKAB might implement. Yes, yesterday's practices, this image is actually from 40s, when operations were heavily relied on manual work. Of course, with that knowledge of that era, there were high risks for the people and equipment, and of course, low efficiency. LKAB around 40s introduced the Swedish mining method. That Swedish drilling method. That drilling method, with that method, only one driller can operate the drilling equipment, which until that time, at least 2 operators were required. Another slide here shows the loading machines of that era. As we can see, smaller tunnels, the operator was not so protected, and the machines were, of course, smaller. Here we can see the technical development in a chronological order at LKAB with respect to automation. Around 50s, the haulage went automated. Then the train haulage went automated. Then we turned to remote control the rail switches for the railway system in the mine. Then automated trains around 70s. At the end of 70s, we had the first fully controlled pelletization plant. Then during 90s, a system for real-time information that was introduced to monitor and collect data from the mine and the plants. At the end of 90s, LKAB tried a fully automated loading system. Then we introduced the remote control rock breakers and production areas. And in the decade of 2010-2020, I would say, an extensive wireless network has been introduced in the mines, both mines, Kiruna mine and Malmberget mine, with more than 3,700 Wi-Fi access points. That means the entire both mines were had Wi-Fi access. Then the engineers could gather data, could inspect areas with when the machines were in operation, and assess in real time cases related to production and other operations in the mines. During the decade between 2010 and 2020, and ongoing, of course, the idea of digitalization, so that even before that, but the foundation was set in with a network installation. Then the SAM, Sustainable Underground Mine, that project that LKAB has been working on since more or less 2018 or 2015, in that era, which is to convert the mine into digitalize the mine with the equipment connected to each other, gather data. And right now we have an autonomous mine in Consol, which is close to the Kiruna mine, which where we try all these cutting-edge technologies. Today's practices, we are in a much safer and much higher efficiency. We use much safer and much higher efficient equipment, and the work changed from heavily manual work into heavily mechanized work. Our operators are located in safe locations. We have remote control machines, drilling machines, for example, as we can see in this picture, and also some machines that are used for production. The loaders, if you compare that machine with the previous one, is much safer, bigger to have higher productivity, and the cross-cut areas, the mine grow larger. Today, our production is 85,000 tons of iron ore per day. The final product, the steel that is produced, is equivalent to 3 Eiffel Towers a day. Then tomorrow, the concepts of tomorrow, of course, AI is involved. Together with AI, data automation. That means we have the 3 cores of digitalization. First is to inspect, to gather information about the existing conditions in the mines, to plan, and then to give the order to the machine to perform a task. Of course, all these pillars exchange information with each other, and advanced algorithm and sophisticated algorithms can learn and optimize the process, make it safer and more efficient. Here, the inspection can be done by means of various vehicles, aerial vehicles or ground vehicles. For example, fully automated drones or ground robots. Spot can be one of them, or a combination of these 2 machines in areas where the robots cannot go because of mud or water. Then the drone can be deployed and further investigate the area. All this information and data will go into plan, so to have an efficient and safe plan to perform the tasks. Then all that information from the plan will pass into the machines. In this picture, what you see here is a battery-driven machine in the mine that has the possibility of work autonomously underground. Then the future looks that all this system will run as an autonomous unit, of course, with supervisors, and increase the safety first of all, and the efficiency. Here we can see the progress that has happened in the SAM project over the last 10 years and forth until 2030. At the beginning, we had isolated systems that the systems didn't talk to each other. It were isolated units. Then we jumped into connect operations, where, as we saw before, we started the installation of the Wi-Fi point. Then we start gathering data in real time. Then we went to integrated operations, where we could run remote diagnostics, see the condition of machines in real time, and the way forward is the remote control, the remote operations, prescriptive maintenance and analytics, real-time information, remote control. So less and less people will be exposed in the mining conditions. Of course, intelligent systems and electric ships. Finally, the vision is to have autonomous operations where systems will communicate with each other, as I mentioned before, exchange information, take decisions for much more safer and efficient mining operations. Then, yesterday, conditions, we have been 100 years of proud history with challenge and development. Manual and risky work, low efficiency, and short planning horizon, as well as reactive work. Today's the information and data intensive, data analyzing decisions taken by staff operators and all over the organization. A high grade of automation is in isolated areas, long-term planning, and high volumes and capacity. Tomorrow, the mine is sustainable, safe, and efficient. We try to close the gaps between our systems, establishing an integrated seamless platform for information and data. Recently, we have been working with Spot. Spot is a dog-like robot by Boston Dynamics. LKAB right now has 2 spots for testing the suitability of these machines, of these robots, in mining conditions, because there is dust, there is humidity in the air, and we know electronics are a bit sensitive on these conditions. These machines, these robots, can be used for different purposes. For example, to inspect areas or to scan areas after a production blast, to measure the gases of an area again after a production blast. In case of a fire, these robots can be equipped with rescue system, rescue payload, which can approach the area, give to engineers a real-time perspective of what is going on in that area, and then people can take decisions based on given information and not assumptions. Spot by itself understands its surrounding environment and adapts to it. It understands if it is slippery, if it is muddy, if there is water, and even if there is low light intensity, Spot can operate. And of course, Spot can be programmed to explore an area of the mine or perform a task during the quiet hours of the mine. Quiet hours of the mine are usually after blasting, during night, where the mine is more or less empty. Then we can program Spot to visit to freshly blasted areas, give us the measurements of the air quality, the condition of the performance of the blast, so the engineers in the morning can plan the rest of their work. Then training Spot. So far, Spot has been underground about 6 months in the mines, and we have used it with normal cameras, night vision cameras, scanners. We have done repetitive scanning processes of different areas to see the stability of the compatibility, so to say, of the data from repetitive scans, and we keep working on these tasks. All the information and data can be accessible in real time by our engineers, and this is the beauty of these machines. LKAB has historically been testing cutting-edge technologies and innovative technologies. I believe a bright future is ahead of us. Thank you.
We don't have any time for questions now, so we need to go over to our next speaker. But thank you. Our next speaker is David Degerfeld from Boliden. David is currently leading a skill team developing new technologies for process control in mining at Boliden and is the program manager for Boliden's newly started research and development program AI in mining. Welcome, David. You will talk about artificial intelligence maturity at Boliden.
Thank you. I was just trying to unmute my microphone there. Classical problems there. Yes, thank you very much. Yes, I want to talk to you about the maturity of artificial intelligence within the organization. I think we have often in this kind of conferences, we as engineers, we tend to talk quite a lot of technology. So I would like to go beyond the technology and look at other factors that will impact the artificial intelligence in the future. But first, let me just start by sort of have a small mention of this artificial intelligence program that we have started at Boliden now. This is a new initiative started this year that aims to focus our internal research in artificial intelligence, and that is artificial intelligence in the quite general sense, applied to all kinds of areas within the mining and process industry. So we're currently starting up that work, and we will have high hopes for what we'll accomplish in the following years. I don't know if you've seen this picture. I think I saw some similar stairs in a previous presentation where we sort of list the maturity level of artificial intelligence of companies. There are several versions of this one, and this particular one is from Global Mining's Guidelines Group. I think it was published in one or 2 years ago. But as we started to look at this staircase, we sort of realized that, okay, this is quite applicable to our organization. And I did a quick survey on trying to identify where we're currently at within Boliden, within this stair. And I think we have reached somewhere around level 2 in sort of a foundation of artificial intelligence. If you look at level 1, the basic sort of step is where you start to navigate within the field of artificial intelligence, exploring possibilities, understanding what the benefits are. Today we sort of take these benefits for granted or self-understood, but I think it's still worth to give that some consideration in all AI initiatives that we undertake. We have also done quite a few case studies, and sometimes those case studies have been with packaged solutions where some third party or supplier has just provided an artificial intelligence solution for some very specific application. Case studies we've done has involved some predictive maintenance, but also one of the more successful studies we did was trying to predict disturbances in the process, where we showed that we could predict disturbances up to 2 hours before they happen using AI technologies, which could be very beneficial because that would give the operators ample time to take preventive actions and hopefully avoid an accident or perhaps a discharge into the environment. At level 2, sort of a foundation, we'll see more experimentation and more thorough investigations in what wants to be done, and also pilot studies are done on real projects that will eventually be implementations, and that is currently where we do a lot of work now. And consider impact on people, processes, and technology. That is, I was hoping I would be able to check that box after this talk, because that is exactly what I'm doing right now. So that maybe we could take this step here and now. Looking ahead at the future for us, and perhaps the history for some of you guys who have come further up these stairs, we have yet to see a sort of integration into our daily operations. We haven't decided on a platform. The mining industry, I think you may all agree with me. I have a background in the telecommunications, and mining is pretty conservative, and robustness is very well appreciated. So deciding on an artificial intelligence architecture takes quite a while, and it needs to prove itself before it can be deployed and well received throughout the organization. Change management comes naturally, or is needed. It's essential for getting to level 4 and level 5. At level 4, we are actually doing some kind of attempts or pilot studies that actually belong to level 2, but on the solutions in decision supported level 4, and that is mostly where we have sort of low-hanging fruit with essentially where operators take actions. Those actions are recorded in the DCS, and we can use that as labels for training the process data in for instance, a neural network that would recommend actions to the operators. But if we look very much ahead, perhaps even beyond level 5, if you see in level 5, there is sort of a mention of an in-shift re-optimization. But if we look to level 6, which is not here, it's when you have a fully automated mine or your autonomous mine. We don't see that we have that many people running our equipment, because if we have these automated trucks, we have a fully automated mining cycle, there wouldn't be shifts, because no one would, the machines, the artificial intelligences, as we have all mentioned previously, they don't require breaks. They work 24/7. So that maybe is not applicable. But there are some other considerations that we need to consider. I kind of like this picture because it sort of symbolizes the hero of the current mine. And of course, the heroes are the two persons you see down there to the left in the picture, standing next to the big truck. We have our operators that do all the heavy work, and today those are the heroes of our operations. Without them, we couldn't do anything. But what will happen when we have a fully autonomous mine? Who will be the heroes in that organization? Who will drive the development? And what would their role be? Where in the organization would there be? Currently, let me take an example of a challenge that we will see ahead. Take the IT organization. IT organizations are today often organized in a support function, central, not considered part of the daily operations. But even today, we could ask ourselves, who is running the operations? Who is our hero? Well, the operators would be the answer today. But when we have artificial intelligence, who would be the hero, and where would they be organized? Will the IT department perhaps be the core of our organization and support the operators that come in and help up when things go wrong? Would they be considered a support organization? We have a lot of questions to ask ourselves when it comes to the organization, and what kind of impact that has on our view ourselves as both as an employer, but also as an employee of an organization that is run by artificial intelligence. So I'm sorry I couldn't give you much answers, but I was hoping I could give you some questions to think about until we have found the answers together. Maybe we will discuss the answers on the next conference. We'll see then. Thank you.
Thank you, David. We need to go on with the program, but I just wanted to say thank you, and we will see you again at the panel discussions, where you will be joining us as well. Our next speakers are from the Chilean mining company Codelco. Leonardo Angelucci and Alberto Laudio will be with us and tell us a little bit about how Codelco is seeing AI and a short summary of what they are doing today in this field.
Hi, hello. My name is Alberto Laudadio, and I'm glad to be part of this webinar. Thanks for having us. I'm data manager at the National Copper Corporation of Chile, as part of the advanced analytics team in the VP of Technology. I'm mainly in charge of our data lake and corporate data governance, working with the data architect and our team of data engineers and the data governance leader. Here with me is Leonardo Angelucci, who is Agile Manager in the same Advanced Analytics team. Leonardo is in charge of the implementation of the Advanced Analytics Initiative and the Data Scientist teams. I be telling you about the purpose of our team and the key elements we rely on to achieve our goals. And Leonardo will be telling you about how we are doing the project and what are our next steps. So, our purpose is to optimize copper production, reduce cost, and reduce risk by making data-driven decisions through the implementation of advanced analytics. To achieve this challenge, I will be introducing the enablers that help us to bring them forward in an ordered, standardized, and sustained way over time. First, we have our corporate data lake. We are in a continuous development of our centralized data repository in the cloud. Yes, we are working with Azure, in where we store near real-time information from the OT network, like sensors, tags, IoT, and context information to feed our analytical models. Then, our corporate data governance, we're implementing the project that will build Codelco's single source of truth, democratizing the corporation information in a timely, secure, and reliable manner. Then the demand management is an iterative process. We are periodically reviewing our roadmap of advanced analytics projects, always prioritizing those of greater value and aligning our portfolio according to the needs of the corporation. Then the advanced analytics projects. With this initiative work under agile methodologies, we build systems that fed by analytical models, challenge the strategy of the operation with recommendations that help operators make better decisions to adjust the variables in the control system in order to maximize production. Leo will talk in more detail in a moment. Then the continuous digital improvement. Once the analytical models are in place and the committed value has been delivered to production, part of our team continues to work to maintain the value contribution, looking for new opportunities to increase it and addressing new business needs. So please, Leo, tell us about our projects.
Thanks, Alberto. Hi guys, I'm happy to be here. I want to tell you about one of the main projects in Codelco. Let me share one video about that. Sorry about the video text is in Spanish, okay? But I will be explaining over the video, okay? I hope you are seeing my screen. Like that. Okay. Well, the first project I want to mention is the name is MINCO. It's Mine to Concentrator in our Chuquicamata division. The scope of this project is to maximize the copper output with one particularity. We are selecting the optimus mineral combination. Maybe you know this concept as blend or blending. We do that with three different sources, the open pit in Chuquicamata, the underground mine in Chuquicamata, mineral from another northern Codelco division named Radomiro Top. Okay? We define this optimus or this combination based in the current division concentrator context and actual configuration. I mean, we are talking about the line with the sag miles, the grinding miles, the rougher flotation. Despite of we are modeling each process separately, the main objective to maximize the Cooper output work as a one big process coordinated between all these small pieces of our line of production. Okay, what we do in concrete, we create a recommendation system to the operators in the central control room where the remote operation is, always with focus in give to the operator a few modifications in the control variable limits. Okay, this is our core in this project. All based in advanced analytics and machine learning models. Okay, I want to give you a few highlights about this project. This project is our top value project in our portfolio. Okay, we expect a big value at the end of the road. The project execution is based in the Scrum Agile framework. And the project continuous operation is based in a traditional Kanban framework, okay, with defined stations. Very, very traditional Kanban, okay? A very important thing to mention, let me stop share. One very important thing to mention is we never work alone, okay? We always work with the operational experts of the division. We have a mixed team. In fact, our product owner is a process expert in this project. As analytics team, we provide the data scientist, the data engineer, the scrum master, the full stack developers, all the technical hands for the project, okay? Another highlight of the project is this project is 100% cloud project. As Alberto said, we have data in near real time for the tags of the sensors. All of our machine learning models are executed in our cloud environment, and the recommendation system and the KPI reports are mounted in the cloud too. Okay. I think it's important to mention that our advanced analytics model are based in historical data. Okay, all the time we are generating 1,000 of possible scenarios, and we only pick one, the best one, for the current context operation to give the best recommendation to the operator. That as I said before. The other thing is we create a recommendation system to complement the operator in the central control room. We can't replace him. Okay, we suggest different values for the control variables. However, the operators determine or select if she or he will apply that recommendation. Okay, we try to help he or she to do in the best way his work. Okay, and the last thing to mention, I think is very important. From the beginning of each project, we constantly execute proof of concept, POC, to challenge the current operational maximum and minimum limits of the active involved in the process. For example, we stress the limits of the SAC miles. We have very good experience with increase these limits, that use that to benefit in more Cooper generation. Okay. I think we are just in time. I have another project I may be commenting another session, but I want to give you just the title. We have hydric resource optimization in another division named Il Teniente. The scope of the objective is the same, maximize the Cooper output. But in this case, we try to use the available water in the best way possible. Okay. If you want, we can have a detailed meeting for discuss that, but it's a really interesting project too. Okay. I want short to comment next steps for advanced analytics in Codelco. We will replicate this project, Minco, and the hydric resource optimization in another division with similar configurations. and we will start prescriptive maintenance project with a few selected activities in other divisions. Okay. Thank you very much. And as I say, if you want to discuss more detailed, technical, or whatever, you can contact us. We are open to that.
Thank you so much, Leonardo and Alberto.
You're welcome.
It was really nice to get your views of this. So we move on with another studio member, Ola Pettersson, manager platform development at Epiroc Rock Drills in Örebro, Sweden. Responsible for the automation platform in all Epiroc's computerized machines.
All right.
All right.
Thank
Welcome,
you.
Ola.
Thank you very much. Okay, so today I will speak only about underground loaders. Actually, we saw before when Amy showed some research cooperation with us, we saw the drill rigs and some optimization in other aspects, but I will keep this short and tidy and only speak about loaders. So as you know, we do drill rigs and we do loaders and trucks for the mining business that you know already. So the first question maybe then, why should we bother about going autonomous in the first place? Because it's perhaps cumbersome, expensive and complicated. So we believe strongly that autonomous loaders will increase safety and health of the operators. It is a dangerous environment, of course, but we have also seen in many cases that the ore production can actually increase as well. And this is a lot due to that we can work 24/7. Actually, a little bit about what Fredrik said earlier as well. We can increase production with autonomous machines. And in that sense, we will also be able to save time and money for our customers. So this is why we bother about this anyhow. Okay, so here we go. This is our robot. It's a beast, 38 tons in total. It takes 14 tons in the scoop. And how do you make this machine smart? It's a lot of steel and it's very heavy and run on diesel in this case. So we need to add some sensors to it. So we add a better wheel encoder, a better hinge angle encoder in order to know exactly how much we are turning. We're going pretty quickly in some cases, so we really need to keep track of where we are heading. We put on an IMU in order to get the acceleration in all directions. We need to see the walls, of course, and actually the walls are the main input to our navigation system when it comes to understand where we are, because we build maps and then we compare what we see at every time. And then that is our position estimate. And of course, everything is made in a brain. We add a computer for that. So this is how we add AI to a machine. And I will also show you guys a little movie here that you can find on YouTube. I will not show the full video because the interesting part starts a little bit ahead. So this film will show how we use autonomous loaders, I hope. Today, kids are running in this movie as well. So here we go. This is the control tower. The people, the operators, they sit here in a cozy, warm and clean environment, and they send down missions to the machines that are operating in the mine. And we can do fleet management from this level, and we can operate basically everything from there. This is a little illustration of block caving. That is a mining method, particularly well suited for making autonomous loader operations, but I will not speak about that because that is not my area at all. So beneath the big ore body, you have all our autonomous loaders. It's a little bit like ants going back and forward here. So the idea is that there is no operation, no people sitting in the cabin at all. And today we need to put autonomous machines separated from people and machines with people inside them. So the idea is that we drive the machine to the secured area. We put them inside the safety system. This is a laser curtain, and we stay inside this safe area, speak to the guys in the control tower, and then we can drive in the machine in the autonomous area, and then we let them do their job there. So this is the process. And I think also you saw in Amy's picture there, it looks very similar to this, because I think it is the same mining map. So what we also do, we put AI on the machine itself in order to do proper navigations. They are not allowed to collide. They need to know where they are and so on. But we also do fleet management and optimize the process in total. So we plan for all these loaders, and the idea is to not wait. So this is bad, actually. The idea is to work and fill material in the crusher here and keep everything clean and tidy and working smoothly. So we do fleet management as well. So this is what we have today. So if we move on a little bit, what are our future challenges when it comes to AI? So I would also say that these AI challenges that we have already today, I would say that is a little bit more of a classic robotic problem and optimization problem. But I think these two that I picked out now here, maybe we need to go a bit even further and also bring in machine learning. So this is interesting. So one thing that is problematic, and we have been working for a while, is to fill the scoop automatically. So as you saw in the previous film there, we do navigation and dumping autonomously already today, but the remaining challenge is the autonomous loading. And when I looked in my folders yesterday to find a suitable picture for this, I found a folder named 2014. So this picture is actually quite old, the top one there. We did some experiments in Kvarntorp, and we thought we had solved the problem actually, but when we came to another pile with another material, it didn't work as good as we thought. So this is a real challenge actually. And we have also made a small project together with Algoryx, and they do machine learning totally in simulation actually, and we will see if that can help us out with this problem. So this is definitely a challenge. Interesting one. Another thing I think we could spend some more time into is sometimes the walls move. So we have seen some customers, they fill materials and then they dig it away and put it somewhere else. And again, we think we have a good solution on map creation. You can run your machine, create your maps. We can go super fast autonomously. The driving is robust and good. But the challenge here is when the mine moves around these piles. Because, of course, if you make a map and there is a wall, and then the next time you come, there is a drift instead and the other way around, it's problematic. So here we need to come up with some even better algorithms for the mapping and navigation problem. So here we have another ongoing project. It's a WASP program project, as Amy mentioned, a big finance institution for that. Christine Nielsen is our industrial PhD student, and it's together with Linköping University, and she has addressed this particular problem actually. So that is actually my presentation. It was kind of quick, I hope. Questions maybe.
I think maybe we'll take the questions for later.
Afterwards.
Yeah, afterwards.
Cool.
In the panel.
Yeah.
Because you will be with us in the panel as well.
I will.
Yeah.
I will stay. Yeah.
Great. Our last speaker today is Iman Vakili from Sencept. He's earned a PhD in David Segerfeldt and George Nikolakopoulos. Are you still with us? And with us also we have Anders Johansson, which will be our moderator for the panel. Anders is a senior advisor for the Strategic Innovation Program, Process Industrial IT and Automation. And he's also senior project manager at AI Innovation of Sweden. Welcome, Anders, David. Do we also have George with us?
Yes.
Yes, perfect. All set.
Okay.
Okay.
Yeah. Okay, thanks for the introduction. We'll go straight on the questions and the discussion, and then we will continue to focus on AI innovation for the mining industry. And I would like to start this panel discussion by asking you, each one of you, based on the areas or the context you are in, meaning research in general, mining operations in general, and equipment product supplier in general. So the question is, how is Sweden doing in these areas, in your areas? We know it's a global, competition is global, meaning are we leading? Are we just following? Are we falling or lagging behind? And I would like to start with Amy, research in general and Sweden. What would you say?
Yeah, this is a question I get often, and it's a very difficult question to answer because also a lot of research is done in sort of international groups. I think we all know that when it comes to AI research in Sweden, Sweden missed out on taking the lead. And that is the reason why a lot of these initiatives have kind of popped up maybe about 3-4 years ago to push Sweden and make sure that one doesn't lose that lead. But still, with that said, I would say that the prerequisites in Sweden to become a leader are all there. You know, there is a long history of engineering innovation in this country. There is a very, very conducive environment for doing free research. What I mean by free research is, you know, going from that first idea to something very concrete. And there is also, in my opinion, a strength in Sweden in terms of exploring AI when it's connected to fields like automation. In fact, if you look at some of the research groups in Sweden who are exceptionally strong, they come from control theory and automation. So there's a lot of potential for us to take the lead. But if I'm to be truthful to my own assessment, I would say we're not in the lead yet.
Okay. George, would you like to comment on that?
Oh, I agree. We are not in the lead there, and I think it's a function of investments in the field. So we have the potential. We are recently I was writing a proposal about an AI excellence network in Europe, where I think Sweden, in the worldwide level, was maybe, I don't want to say the exact number, but let's say in the top 10, I think. So it's very good position already. Okay, so I think it's a function of investments and throughput. So that's the only barrier, I think, to, as Amy said, to become even stronger and stronger, I think.
And David, if you could talk not only for Boliden or for the mining companies in general, what would you say?
Well, I would say that we're definitely in the top. Whether we're number one or only in top 10, that would probably depend on different areas. I mean, there are many aspects of this, but if you take Boliden with our strong progress in underground automation, that I think is way beyond what you find in other parts of the world, and also look at the huge ambitions and progress that LKAB is doing within the SUN project. I think we have a very strong case in Sweden, and that is quite natural with our history and our sort of natural incline to development and cooperation in between fields and also in between companies.
Okay. Ola, a global supplier as you are, I guess you know a lot about what is happening out in the world. What would you say about Sweden's position?
We are in the lead. No, I'm just kidding. No, I think I agree with the earlier what you've said here, Amy and David, and I also agree that a few years ago, maybe even more, maybe 20 years ago, I would say we were very well suited, but for some reason, other countries and a lot in Asia, I would say, pumped in money and resources and research, and I think they actually accelerated a lot faster than the pace we had. So I think for 20 years we have been dropping off, maybe for a while, but then I think now super lately with WASP and other internal initiatives, we are now pumping in money as well, and I think this network is a good thing actually for that. So maybe we are trying to get back to the lead again. That is my idea on it. And also, if you ask me how much AI is in the company Epiroc itself, I would say it's rather poor. Maybe we do smart machines, but internally we are still working with pen and paper. We don't use AI internally actually. So there is a long journey. I think Boliden uses AI a lot more when you make decisions
every day.
And every day, but we do not actually. So there is a lot to do, I think.
Interesting to hear. And Fredrik, that's more general then. What would you say from a more general perspective?
Yeah, I can agree with Ola that Asia is taking the lead. And if we see in international conferences as well, we organized world's largest robotics conference in 2016 in Stockholm, ICRA, and it's peer review. So we don't know who has written the papers, even though when we see the result, it was over half of the papers from China. So China is producing enormous amount of research in this field. And we are proud that we have WASP project, but it's tiny compared to what China is spending on these fields. So yeah, it's hard. Also, Sweden is a small country. To compare it to China is a bit unfair.
Sure.
But their universities and they are doing a lot more than we are, and that's sad. And we often think that we are in the top. If you ask leaders in the companies, they say we are the best, and we were the best 20 years ago, but we aren't anymore.
A more open question than that any one of you could ask is, in many cases, we see that finding a best practice is one way of finding actually what we would like to do in the area of mining. And what I've seen in many cases in presentations that the best practice areas coming from healthcare, from how to use languages and so on. And my question is, and maybe I should start with David or with Ola for that, where do we find the best practice? Of course, not in Boliden, probably somewhere else.
LKAB. Oh, that's a tough question. And it must be related to mining, best practices in AI in mining.
Yeah, and
I think it's the one that dares to try, but I think we do that a lot in Sweden. We are not hesitating. I saw, for instance, LKAB, you started with autonomous loaders in 1999. I think it was the first autonomous loaders worldwide. So as long as we dare to try, I think it's good, and learn and discuss the results. But yeah, hard to say where they are. You say, David?
Yeah, it's a difficult question, a very open question, but I was very happy to see Codelco's presentation with their integrated, very agile ways of working in their data analytics center. So that was really inspiring to see that they have reached that level. That is very impressive, and I think we have something to learn from there.
Yeah. George, you have been in the European Union with the projects. Would you say, do we have best practice that could be good input for the mining industry?
Yes, I think in general, the academia or the general state in AI and robotics or field robotics, it's, let's say, beyond the levels of adaptation from the mining industry. So, but the mining industry in Sweden is, I think, very open, and with a gap maybe of 4 or 5 years, they are evaluating and demonstrating concepts that in academia are well, let's say, agreed and evaluated. So I think that's very good. Other countries might have a time delay of 10, 20 years or 30. So I think we have a very, I think the mining industry in Sweden is very open to, or it has a very good radar to see what's happening around through us, the researchers also, and other experts, and evaluate things that they believe that have the proper TRL for the real problem. So I think it's working very well.
Anyone want to comment on that?
Yeah, well, I think I can chime in and also agree that we talk about Sweden being a small country, which it is, but our weakness can also be our strength. And the fact that there's a very small distance between different actors can allow for a much faster sort of turnover if we can also accelerate that process with a little bit of boldness and a little bit of courage. And in AI and robotics, it requires even more boldness and courage, as we heard from Frederick. There are risks. It's an uncharted territory, and we are in a setting where there are a lot of regulatory aspects that we still don't know if they keep up with the technology. But I still think the time for action is now. And if we can build strong sort of consortia with academia, with industry, and with all those people who are important in between, then maybe we can actually prove, do proof of concepts and test and demonstrators. I think that would be, maybe not a best practice that we have had, but it could be a winning formula for going forward.
Okay. One of Sweden's areas of strength considered to be is collaboration, and Irén mentioned it at her welcoming speech. Amy also mentioned it, collaboration, and in AI Sweden, they highlight text like "we collaborate to accelerate applied AI," and I guess many in the seminar are probably very interested in finding ways of collaborating. So let's play with the idea that you are in a collaboration project or in a collaboration environment, ecosystem, where all these type of partners are involved. What is the value that you could provide? Ola mentioned safety, productivity, and efficiency. And then I would start also this time with Amy. What can you then from research do in such a collaboration? What would your main contribution be, and what would your expectations on the other be?
So I'm in the business of knowledge, and it's about sort of contributing with knowledge, but also contributing to produce new knowledge. So, as a researcher and as a scientist, that's what we do. And I think that would be the core contribution. I'm saying it maybe as a cliche or in broad strokes, but I really do mean it. Bringing the knowledge to the field, that would be the core contribution. In terms of expectations, I would expect that a collaboration would make use of that knowledge. It's that knowledge transfer, to be able to uptake it, make use of it, and then run with it. and sometimes we can get, you know, people who are a little bit surprised when they deal with academia, because people say, well, don't you want to make money out of this? Or how do we protect your IP? And we're just go take it. So
that's the Swedish universities. That's not what we hear from US.
No, that's true. No, but knowledge is my short answer.
Okay, George, comment on that.
Okay, except from knowledge, I think we could jointly help. We could have a mutual inspiring collaboration defining the future, because many things that maybe in industry believe that they are science fiction, for us might be our everyday. So I think we are more towards the future and, you know, presenting or building concepts of, for example, collaborative robots, high levels of autonomy, things like that. But I understand there are some, let's say, how to say, it's a bit difficult to adapt these new technologies nowadays, but our role is the future, to look 5, 10 years ahead, to have a vision and try to, hand in hand with the industry, revisit this vision and make it very realistic, I think.
Okay, David from Boliden, what would you say?
Well, I think we can provide a playground. I mean, we're sort of the base industry, and I suspect that we're sort of expected to also bring the money.
That's a good idea.
In the end, that's one key factor, but what we also can contribute with, I hope, is some sort of feeling of where the money actually is, where these ideas can be applied and turned into profit, which in turn would profit us all. But we're sort of in that end of the value chain.
Okay, Ola.
Yeah, it is. It's not straightforward, the idea here. So we are super happy to cooperate with our customers, of course. That's important, and we are super happy to cooperate with the universities, of course. But when it comes to cooperate with our competitors, it's more problematic. We want to sell our machines to the mining business, of course, and if we give away IP to some other brand selling loaders, it's problematic. But I think if you look beyond that and are a bit far away on your products, then there is, of course, cooperating aspects also. And I think one thing that we have talked a little bit about is the legislation and ethics and all that parts. I think that is interesting, and maybe our competitors have the same ideas there, and we need to get forward on the loyal aspects of autonomous machines, for instance. That is not what we compete with. That's more of a common enemy in that sense.
On the seminar we had approximately a year ago in Luleå, it was mentioned from the mining industry, many people there, that they said it was difficult to find areas in the mining industry where it's the best area to apply AI to get valuable knowledge and so on. But the subtitle on that seminar was Hype or Hope. And now it's been 1 year. So I would like you all, as a final statement from you, say, do we have hype or do we have hope? Is it a matter of go to bed and pull something over your head? So hype or hope? And now we start with David.
Love that title. I wonder who thought of that. But is there actually a contradiction there? Couldn't it be still be a hype and still be hope? That's more of the same thing in my perspective. I think AI is there's a lot of hype in it, but there is a power in the hype, because it's very easy to get attention. It's relatively easy to motivate things with, hey, it's AI. And we can get some sort of automatic traction and get a push forward. But with that comes also responsibility. We have to deliver.
George, hype or hope?
It's a big hype that generates big hopes. So, yeah, for sure, in the European dimension, it is a hype that is decaying. There is no doubt about that. There are other hypes now, circularity and sustainability and yeah, all these things. However, for me, that I'm in the field of robotics more than 20 years, it is a really hope or a vision for me to deploy autonomous machines, autonomous things in real life all these years. So for people that are in the field, I think it's the AI and the current capabilities are creating a big hope for the industry in general for the future. There is a danger, of course, always to use buzzwords instead of real things. So usually when I talk, I never use the word AI. I use the word autonomy, robotics, clear, specific things that we are doing. So when all the people are using the same buzzwords, I think there is a big danger to have diverge also from the goal and the real impact, I believe. So,
Ola, hype or hope for Örebro?
Yeah, I think I agree. I think we could talk about both a little bit. I definitely believe that it is a hope, and we need to get over the hype and do real things and prove it works, and also start discussing the odd and soft questions about how much AI and where should we put it.
Amy?
Both.
Both.
Yeah, I agree fully with what Ola just said. And I think that we can achieve more hope if we get over the hype.
Okay, I think it's time for Jenny to wrap up. Thanks a lot for all you that participated in this discussion.
Thank you.
Thank you.
Thank you,
Anders.
Yeah.
And welcome, Jenny.
Hey, thank you, Lotta.
Hey.
And thanks to the whole panel, and thanks to all speakers today. It's been a really interesting afternoon, and I think we've seen a great variety of potential applications for mining purposes. We also seen from Fredrik a lot of really interesting and sort of mind-opening examples that we could, I think, be inspired from in the mining industry. We've learned also today that development is going extremely fast in this area, and I think George said that what's now science fiction will be sort of implemented already in 10 years, and that gives a lot of hope. Amy also talked about that we are not leading, but we do have a national ecosystem present in Sweden that can work together towards being more in the lead. And I also know that Swedes are known as early adopters in all through history, I would say. So probably we can use this at least somehow. We've also seen interesting enablers for this, like the intelligent radars that Iman showed us, and the future machines that Epiroc showed also. That's also not so much future, that's already actually there. We've seen from the mines really interesting presentations, and I know LKAB worked already in the late 80s, early 90s with neural networks, which is also AI somehow. We see now the Spot example and really interesting. And we realize that the next step in automation requires more use of AI and machine learning. Codelco showed us they're really, I would say, I didn't know about this, that they were doing. It was really interesting to see what they're doing, and that they're actually already using this as decision support, but also stating that it supports the operators, that it's the combination of AI and the operator's knowledge that is really great. And we look forward to see what's going to happen in El Teniente with your continuous work and with the work on predictive or prescriptive maintenance. That will be the future. Boliden showed us an ambitious way forward, also stating that, yeah, there's a lot of potential, but we're not quite there yet. So I would like to sum up what we've seen is that we're not yet using the full potential of this, of course not, but the development is going so fast. And I would say that maybe we could aim for being at least the lead in if we're not leading in developing this, at least leading in applying this in the mining industry in Sweden. That would be great. And we, of course, in the Mining Innovation Program will do everything we can to support this and support the acceleration, and try to discuss after this how we can do this in the best way, given what we've learned today. So before I end today, I would just like to give a special thanks to Mr. Laudadio and Mr. Angelucci coming all the way from Chile to present today. So that's very appreciated from Codelco. And I see that we have lots of things that we could learn from you in Chile, and that we could sort of also work on together. So thanks to everyone, and thanks for all these insights that you have given us today. And I leave it to you now, Lotta.
Thank you, Jenny. 1 minute to go. On time. Yeah. Oh, no, it's 4 o'clock. Yeah, a big thank you to all of you here and all the speakers on link and all the listeners out there. Mm-hmm. It's been a great day and I've had fun. I learned more and I want to learn more. Great.
Thank you.
Thank you.
Thank you.